I've had the MMU2 for my Prusa Mark III for a while now. I thought it'd be a great time to show you some of the tips and things I've learned along the way. The Prusa MMU2 is a multi-material unit that can be used with the Mark III or the Mark 2.5 upgrade. It'll accept 5 different types of filament or colors, use the stock extruder and hot end, and make multi-material models. Now there is a learning curve with the MMU2, and it's definitely not perfect. But with a few tips and tricks, it can be a lot easier to use. And the first thing I'm going to tell anyone that has an MMU2 is make sure you're using the latest firmware for your printer and your MMU2 unit. And to check that, click your LCD knob, scroll all the way down to support. Your printer firmware will be right here. As of today, January 23rd, 2019, 3.5.1 is the most current version. If you scroll down a little lower, this will be the firmware for your MMU2. Right here. As of today, 1.0.3 is the newest version, so you're all caught up. If you need a newer version, you can get those from the Prusa 3D website. After the firmware has been upgraded, there's one huge tip that I can give you, and that is use consistent filament. I can't stress this enough. And I'm talking within 50 micron or less either way of the 1.75 millimeter. I have good luck with Filamentum brand, but there's a lot of good brands out there. They just have to have that consistency. And that's just because of the way the MMU2 works. All the idler bearings are on one shaft, and all the extruder gears are on another shaft. And there's very little room for dynamic adjustment for a filament that's too fat or too thin. And it's going to lead to load and unload issues, which could lead to skipped layers. So again, consistent filament. Moving on. Now let's move to some maintenance type stuff. This is from the back of the MMU2. This is the door that has all the idlers in it. So we're going to remove these 2 screws. Be careful, they're spring loaded. And that's going to give you access to all the drive gears for each filament. Now you can see there's a lot of different particles in here and strings from the filament. You need to clean this out regularly. I recommend you use a vacuum. Just have a shop vac handy to clean this out every 100 hours or so. This can interfere with your prints. And while you're in there cleaning up all the particulate and strings, you might as well clean your extruder gears as well. Just use a brass brush and clean out all the teeth so you make sure that you grip the filament every time. Now that all that's cleaned out and looking good, we can check a few other things. The biggest thing that's going to cause you problems with the MMU2 is friction on the filament. You want as little drag on the filament as possible. So it's really important that all of your extruder gears are lined up with the passage and that passage is completely clear. So to make sure they're all aligned, I recommend you use a 1.5 hex wrench and you just slide it down from the front of the unit. Try to get you in and get a little better shot of that. Now it can be somewhat deceiving, but the points on the hex wrench actually line up really well with the valley in the extruder gear. This is a great way to make sure that they're centered left and right. You can just go down each one, make sure they're as center as possible. Next, I recommend you cut off about a ½ meter worth of filament and then undo this festo right here on the selector and go to each one of the extruder lanes and make sure there's as little friction as possible through the selector out the back of the Bowden tube. You can see the first lane here, it's really easy to pull the filament through. You should have very little friction. The only friction you should feel is the tube going out the back. The further it goes in the tube, of course, the more friction it's going to have. But out the back isn't such a big deal. Right through here is where you don't want any at all. I just recommend you go through each lane, make sure there's as little drag as possible. If you feel any, open it up right in here and expect these tubes and the ones that are right in here. Now to the front of the MMU, you want to make sure there's nothing inside this selector body. I've had little pieces of filament get stuck in here. Now you can try to clear them out from behind through the selector lane, and sometimes that'll get rid of it. Make sure, again, there's not very much drag through here. But if that's not working, you can remove your fenda probe. We'll just slide it out. And then remove the ball bearing that's inside here. You can do it with a couple of magnets, or you can just turn it over and dump it out. Once the ball is removed, you can see inside here, this will get particulate in it as well. Go ahead and vacuum this out while you're cleaning everything else out, just to make sure nothing's obstructing the ball. And you can put your ball back in, and then you can readjust your fenda probe. I recommend just putting some filament in the front here, pushing your fenda probe down until the ball traps the filament and you can't move it very easily, and then pulling the fender probe back out about 2 clicks, so around 2 threads. Now remember, if the fender probe is lit, there's an LED here, that means it's not triggered. If it's out, that means it is triggered. So you might need to adjust it a little bit after you plug everything back in so you can see the LED. But roughly 2 threads should be good. So you can tighten that back up. And then also while we're here in the front, check your barrel selector. These are the idler bearings. I've had these screws come loose and the barrel has actually slid one way or the other, and you want the filament to be lined up exactly in the middle of each one of these bearings. It's going to be hard to see on camera, but you can actually see a line where the bearing has come across the filament so many times. If you see that left or right, that's going to cause you some issues. So you might need to adjust the whole barrel. Or sometimes the bearing can just be hung up a little bit. You need to move it from side to side to free it up. If you turn each one and close the door, you should be able to line the center of that bearing up with the teeth on that extruder gear. So make sure that's as close as possible. And then when closing the MMU door, we're done inside here, and you put these screws back in. When you tighten these down, you want to make sure the screw head is flush with the top of the door unit. Make sure you're holding the door unit down when you're measuring it, but these are going to be just even with the top of this door. And to check it, kind of pull on both sides and make sure the tension feels pretty even. If you don't do this and it's not tight enough, you're going to slip on the filament. If it's too tight, you're going to grind through it. Both are going to cause issues. When you're happy with that, I recommend you put your Festo back on, and then you go through each lane from the Bowden tube behind with your filament and make sure all the way to the extruder there's as little drag as possible. We'll take lane 1 in this example, but I'm going to go all the way through the Bowden tube. When you get to the back of the MMU right here, that's a crucial point. Make sure there's no friction in the Bowden tube right there because it can get pinched. You can just move the selector with your hand, make sure it's pretty centered so you're not causing any drag left and right, but then go all the way through this tube down into the extruder. Now there's going to be some drag because this is a lot of Bowden tube, but it should be minimal. It should be really easy to pull this back and forth. And I would do that for each filament lane. Just make sure you don't have anything stuck in there and nothing's holding the filament up. Now let's move down to the extruder body. You definitely want to open the extruder body up occasionally and make sure there's no particulate in there, and if there is, clean it out. You can pull out these 2 spring-loaded screws, and then on the other side, remove this little cover piece, and then you can lift the door open. You can see in mine I've got a lot of little scrap pieces. This definitely needs to be cleaned out. And when that's cleaned out, that brings us to our first mod, and that's this connector right here. The stock extruder comes with this piece right here. It has a brass fitting that a Festo fits on top of, but then that feeds into a small piece of PTFE tube, which feeds into the PTFE that's in the top of the V6. So trading from this tube to this small piece of tube to the tube in the V6 can cause some friction and places for the filament to get hung up. So the best mod that I've seen for the MMU so far is this piece right here. You can print this out and it fits a 10mm coupling that's pass-through, so you can pass this tube directly into the top of your extruder body and bypass this short piece of PTFE. That will definitely decrease the chance of getting jams when trading filament from tube to tube. It cuts this piece out altogether. Definitely check this upgrade out, links in the description. And while you're in here, this is a great time to make sure that your Bondtech gear is perfectly lined up from the top of the extruder down into the V6 tube. You can use your 1.5 wrench again, just slide it in here into that V6 tube and make sure it's dead center. There's really not much you can do about lining up the door gear. If the one in here is okay, then this one will be okay too. And just a side tip, if you have to replace any of these Bowden tubes that help the filament go from printed part to printed part, it's a good idea to chamfer the inside of the Bowden tube. That just helps the filament get in there a lot easier rather than it being flat and square. And the easiest way to do that is to get one of these hobby tools. These are really made for RC Lexan bodies, but they work great for this purpose. So you can take a regular Bowden tube opening that looks like that, and with that tool, you can make it look like that. That makes it a lot easier for the filament to get in and out of. Now let's move on to spool holders. This is what can cause a whole lot of drag on your MMU2 unit. This is what comes with the kit, and I do kind of like the design. Some printed parts and some injection molded trays. It keeps it simple. The problem is, The filament on these two spindles, that can add a lot of extra drag trying to pull it through, as well as through this mechanism. How this is intended to work is you put your PTFE tube from the back of the MMU unit right here. The filament feeds from the spool through this direction, through this L piece, and then it's fed into this arm, which feeds into your PTFE. So when you're moving this direction and the MMU is feeding filament forward, that's all fine and good. But then when you come back out, it comes back through here and out this arm, and it kicks the filament out to the side. And that creates a loop that keeps you from back feeding your filament spool. It's a pretty ingenious idea. But the problem is it adds a lot of drag to the filament if these parts aren't lined up exactly, and it depends a lot on the filament spool size. Also, having 5 of these holders sitting around adds a lot of room. So there's definitely better solutions, and I urge you to look at what other people have done and find the one that fits best for you. And here's my filament spool setup. I've tried to keep it as simple as possible. I've hung all my spools on a piece of 1.5-inch PVC, and then I feed the filament into a board that has a couple of pieces of PTFE in it. And then in the center, that's where the filament can go so you don't backfeed that spool. And then I have a board with a bunch of PTFE couplers in it where I feed the tube from the MMU into, so everything keeps nice and organized and nothing gets crossed, so that creates as little friction as possible on the filament. I really like these. You can find them on Thingiverse, but these help space out your PTFE tubes so they stay a lot straighter. They just clip together around the tubes. You can put one kind of up at the top up here, and maybe another one right down in this area. Something like that, it does seem to help with the friction in the tube. Now let me show you how to get into the secret menu. So before you power your printer on, hold the center button on the MMU and just keep holding it. Now turn the printer on. MMU is going to go through some boot up. Just keep holding. And when you see the first orange LED and the last orange LED come on solid, then you can let go of the button. Then you want to hit the left button one time to go to LED 4, and then hit the center button again. Now the first LED should be green. Now the reason why you want to go into this menu is because this menu allows you to adjust the length of the Bowden tube that comes from the MMU down to the extruder. The reason why this is important is because every extruder gear isn't going to be exactly identical, and every filament isn't going to be exactly the same diameter. So there could be differences in how much the gear has to turn to get a different kind of filament down to the extruder. Now most of the time, if you're using all the same material, you will only have to do this once for each extruder lane. But if you run into a filament that you're having problems with, you might want to come back in here to the secret menu and adjust that one specific filament. But if you're going to come into this menu already, it's good to go ahead and check every filament lane that you have. This can also be helpful if you're creating a new type of spool system, or you're changing the length of this tube to allow for some sort of modification, like we did with the extruder mod. But it is a really good idea to run this sequence. So I'm just going to run through an example. I'm going to load filament in extruder 1. Then I'm going to hit and hold the center button for 2 seconds. The MMU should go to position 1. And it's going to bring your filament all the way down to the extruder. You can see it brought the filament down all the way to the extruder gear, but here's where you can adjust to make it longer or shorter. From the front of the printer, if you do the right MMU button, that's going to bring the filament up, and the left MMU button to move it back down. When you're adjusting the length, you want the last movement you make to be a down movement. So start high and work your way down. I've found that having the filament right as the motor shaft starts is perfect, about right there. You want it to be far enough down where the extruder gears are going to grip it, but not so far that it's going to grind in the extruder gear. And when you're happy with that distance, you can hit the center button to bring it back up, and that will save that length. But I highly recommend you do each filament lane a couple of times just to make sure. So we'll hit the middle button again to bring the filament back down. So it looks like the position was saved and everything looks good. Go ahead and hit the center button again to save it and bring the filament back up. And now you can move on to your next filament lane. So now filament 1 is done and saved. The green LED is on lane 1. That means it's all the way up. In that position, use the right MMU button to move on to lane 2. And then you'll repeat this process for the new filament. So just hold the center button. It's going to bring it down. Judge to see how far it is in the extruder gear. Adjust it left or right. And then bring it back up and save it. and then move on to the next lane. And once you're done with all 5 lanes, just keep using the right button to move all the way to the end of the MMU. And when your lane 5 button has started to flash, hit the center button to save all your settings, and the MMU will reboot. Now your filament length has been calibrated. That's pretty much all the hardware settings I can go through, but there's a couple of other things that you need to look out for, and one of them is filament tips. If the tips are too stringy on the filament, it's going to cause issues triggering your filament sensor. So it's going to trigger the sensor when there isn't actually any filament in there. This is an example of a tip that's way too stringy. It triggers the filament sensor when it's not actually there. So this is enough to trigger that sensor and cause a misload. This is an example of a tip that's pretty clean. This is what you want the tips to look like after the ramming sequence, when it tries to retract that filament. And this is my favorite filament tip test print. It allows you to run through all 5 selectors quickly, changing the filament in and out, and it moves the selector away so that you can see what the tip looks like in mid-print. If the tip doesn't look good, you can stop the print then and change some settings. And if you want to try to tune the filament, I recommend that you start with the Prusa PLA default if you're using PLA, go into filament settings, and then advanced, you can tune these parameters. There's a couple different things I recommend you change, but as always, Prusa provides a lot of information. This is in their handbook. If you want to try to tune those tips, Prusa recommends that you change the number of cooling moves first. And there's cooling moves right there. That's going to back the filament out just a little and try to give it a chance to cool down before it pulls it all the way out so the tip hopefully doesn't string. I also like to try to adjust the unloading speed at start, and then in ramming settings, the total ramming time. Let's walk through a couple of test prints. And you can see with this test print, it's already printed all 5 filaments within the first 20 minutes. And while it's printing, if you're careful, you can manually feed the filament through the front and check and see what the tip looks like. That's pretty much where you want it. It's not that stringy at all. Maybe one more cooling move. So I didn't even start the print over. I just swapped out one of the filaments with a filament that I know was kind of stringy. There it is right there. You can see it compared to this other brand of filament. So let's adjust the cooling moves and see if we can make that better. So we'll stop this print. So my experiment filament is currently on Extruder 3. So let's go into filament settings. I'm going to change this Prusa PLA MMU2. I'm just going to add 1 cooling move. And then I'm going to save this one. We'll just add cooling 2. And then back to platter. I'll change the filament 3 lane to Prusa cooling 2. And let's restart the print and see if that helps. And that extra cooling move did seem to help. Now for a test, let's take that filament back to the regular Prusa PLA. Let's go into filament settings, and let's take the unload speed at start down to 80. And let's run another test print. So moving down to 80 actually made the tip string more. So the default is 100, so just for fun, let's try at 120. Again, the cooling moves are back to default at 1. And I'd say at 120, those were probably the best ones that I've seen so far. And if you're still having issues, you can go into ramming settings. You don't want to change this unless you absolutely have to. And I don't like it that there doesn't seem to be a rhyme or reason for a lot of these settings. When you go filament to filament, the best I can tell you is you're just going to have to experiment and do some test prints. But really, by and large, with Prusa PLA settings on PLA plastic, most of the time the defaults just work. And the last tip that I can tell you before you're ready to start every print, I suggest you go through and load all the filaments. So hit the button, go to load filament, and hit load all. And make sure every extruder pulls its filament in and it's ready to go for the next print. This is going to save you a lot of headache later. And that's what I currently know about the MMU2. Now I've used this unit for hundreds of hours, and I've had some success, but I've had a lot of failure and a lot of wasted plastic. Prusa continuously develops their slicing software and their filament profiles, as well as the firmware that runs on the printer and the MMU2. The MMU2 runs a lot better today than when I first got it, and I'm sure that's going to continue. Now, multi-material printing isn't for everyone. It takes a lot of time, and you currently waste a lot of plastic on prime towers. But in my opinion, it really takes printing to the next level. I've created some models on this unit that I didn't ever think would be possible, and some of my all-time favorite 3D prints. And I'm always excited to see the next successful print. I hope you liked this video, you found it helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.